Today we're going to learn how you can identify a chemical reaction. Yesterday we talked about physical and chemical changes. Remember, physical changes do not result in a change in the chemistry or the chemical makeup of the substance. Chemical reactions do. However, sometimes they are difficult to determine whether or not it is physical or chemical. So I'm going to give you a few clues today. First of all, a chemical reaction involves changes in properties and changes in energy. Changes in properties would be a formation of a precipitate, gas production, an unexpected color change, or a change in the texture or hardness of the substance. An energy change is usually a change in heat. Exothermic reactions are reactions in which heat is given off, and endothermic reactions are reactions in which heat is absorbed. Exothermic reactions usually feel warm to the touch. Endothermic reactions usually feel cool to the touch. As I mentioned before, one of the signs of a chemical change is the formation of a precipitate. A precipitate is a solid that forms from liquids. In the experiment shown, there are two clear liquids. When combined, you see a cloudy substance that formed. That cloudy substance is actually very tiny small particles that formed in the clear substances, and it is now called a precipitate. In the video, there was a clear liquid and a somewhat clear liquid. When the two of those were combined, you saw the orange cloud appear. That orange cloud were actually teeny tiny solid particles, and those solid particles again are called a precipitate. A second sign of a chemical change is an unexpected color change. The two experiments you see have, well, in this experiment you have a yellow chemical and a clear chemical. You might expect a light yellow or kind of a darker clear chemical that would form, but you probably would not expect this reddish orange color that forms. Again, that is an unexpected change. Here you have a wire and a clear liquid. The result is a blue liquid. Again, a color change that is not expected. So in this video, you may not be able to hear the scientist. He's talking about potassium permanganate and hydrogen peroxide. The beaker has hydrogen peroxide in it, and the potassium permanganate is naturally purple in color. So when he adds the potassium permanganate to the hydrogen peroxide, the chemical reaction occurs and it turns it back clear. So again, that is just another example of an unexpected color change. A third example of a chemical change would be the production of a gas. When a gas is produced, we see bubbles. So here you have your two clear liquids, and then in the resultant product, there are bubbles that have formed. In this one, you have a clear liquid and a solid. When the solid is added to the clear liquid, we see the production of the gas in the form of bubbles. In this video, we're seeing nitric acid and mercury being added to the nitric acid. You can see the mercury is the silver liquid that's being poured in. And as the reaction occurs, there are bubbles forming. And this continues until the reaction resolves itself. The last example that we discussed was the temperature change. In these two liquids, the thermometer is right around 25 degrees Celsius. When these two liquids combine, the temperature rises to about 30 degrees Celsius. That means that energy is released in this experiment or given off. Therefore, this is an exothermic experiment. In this experiment, we have potassium permanganate in solid form with glycerin added to it. It's an exothermic reaction. Heat is given off, as is light. In this one, we have an endothermic reaction. The tissue is wet with water. 2 different chemical solids are added to the flask. They're mixed. There is now frost on the outside of the flask, and the wet tissue, which is sitting on top of a board, was frozen to the flask. The temperature decreased in this experiment, making it an endothermic reaction. And that's all I have for you today, guys. Tomorrow or next week, we will talk about the law of conservation of mass.